Compañeros, welcome to the SQL Data Partners podcast, the podcast dedicated to SQL Server-related topics, which is designed to help you become familiar with what's out there, how you might use those features, or ideas on how you might apply them in your environments. I am Carlos L. Chacon.
And I am Steve Stedman. We are two data professionals trying to help others get a better handle on their database environments, either through this podcast, our training, or our consulting practice. Thanks for joining us on the SQL Trail. Welcome to the show.
SQL Data Partners.
Compañeros, welcome to episode 81. I am joined, as always, with Steve Stedman.
Hey, Carlos. I think episode 80.
For schedules and whatnot, so glad you could join us again.
Yep, happy to be here, definitely.
Yeah, and we have lots going on. We have a couple of things planned, one of which we're prepared to start sharing with people, and that is, for those on the East Coast anyway, you're going to be happy to know that Steve is coming out our way, and we are going to be doing the pre-con at the Richmond SQL Saturday, which will be on March 17th.
Or for those of you on the West Coast, you can be like me and fly to Richmond.
Yes, be our guest here in Richmond, in the big small city that is the capital of Virginia, where people get away from DC for a little bit. And ultimately, so we're going to be doing this pre-con. We're going to try to test the waters a little bit here. We have put together lots of good information, and we think that kind of having a full day event rather is going to be a lot of fun.
Yep.
So obviously our topic is on disaster recovery or disaster preparer.
Yep.
And so we have two angles that we're talking about in this pre-con.
So the first half of the day, this has come from when I've presented at past Summit and other events where people have said, oh, you should do a pre-con on database corruption. Well, the first half of the day will be on database corruption, and it will be the extended event or the extended session on everything that I wish I could have covered in a 90-minute session and we couldn't do.
Right.
And then the second half of the day is going to be on disaster recovery planning and things to do to make your SQL Server more disaster aware or disaster proof, if that's the right terminology for it.
That's right. Kicking the tires there and reviewing those plans. And are you really prepared for what you think you're prepared for?
Yep. And then things like exercises and things you can go through so that when a disaster does strike, that you'll be ready and you'll be prepared, and it won't be the first time you've looked at over to the second site or whatever it may be.
Exactly.
Yep.
Yeah, so I think definitely going through each of those different pieces, components, talking about the pros and cons. We did this earlier in an episode, was very well received, and kind of a panel discussion. And so we're hoping that you can be invited in and have this discussion, and we'll talk about the do's and don'ts, even other people's experiences. And so it should be a good time.
Yep. So that's near the end of March, right? What is the date on that?
I'm kind of right in the middle, the 17th of March.
Okay.
So that's going to be that third weekend. We hope that you can make it. If you're in the Richmond area, we'd love to have you. So the event will be put up here shortly. It may not be quite there on the SQL Saturday Richmond site just yet when this episode goes live, but we're hoping that it will be there shortly. So check back. It will be coming out. Of course, if you're coming to the event, you'll be getting news when all those details are available. Okay, let's see. It's time when all those details are available. Okay, let's see. It's time for SQL in the News.
Yes, and just today, it was announced that the SQL Database Query Editor is available in the Azure portal. Now, this is something that's handy if you're using the Azure portal to monitor and keep track of your Azure SQL databases and Azure data warehouses. You can now run queries directly through the portal against those databases. It saves the step of having to open it up in Visual Studio 2016 or 2015, I think it is.
Right.
Or open up a connection from another tool. You can run it right out of the portal. And it's something that's been in preview for a while, but just January 30th, it's just become available as final release.
Yeah, so I think they've had some problems here because this was available in the classic portal, And I think they transitioned it over because kind of been there on the Azure side, on the SQL database side rather, but it hasn't been on the warehouse side. So that's going to be the biggest change, I think, for people.
Yep.
But yeah.
And that's the part, since I've been working more with SQL data warehouses lately than I have with Azure SQL databases, I've seen the preview button there for a while.
Gotcha.
Yeah. So anyway, that's there. Check it out and let us know what you think.
That's right. So let's see. We have an interesting topic today.
Yes.
We're going back to basics a little here.
Well, this is the topic that's been requested for, it seems like, ages.
That's right.
We've been talking about indexes and indexing.
And we have a great guest today.
Yep. And our guest today is Randolph West. Randolph is a SQL consultant at Born SQL. He does performance tuning, optimization, and best practices for disaster recovery. Randolph and I have worked together on several projects in the past, and he's also a recent SQL MVP in Canada. He's in Calgary, Canada, and I believe he's the second guest we've had on the show with an IMDb page.
That is correct. Although he is the first one with more than one line. In talking with him, he's actually the one who pointed us to the fact that Jimmy May has an IMDb entry. He has one as well, with a handful of entries there, and so he is very active in kind of that scene and does directing and acting, and so kind of a versatile guy, Randolph.
Oh, yeah, absolutely. And I originally met Randolph when I created the Database Corruption Challenge, and he was one of the early participants in that. And since then, he is someone that he and I have worked together on a couple of corruption issues where I needed a second set of eyes to take a look at it, more than just the eyes, but more the brain. And he's helped me with a few fix a few database corrupt databases along the way. So that's been a lot of fun.
Yes. Now we're going to break up our conversation because indexes, we could talk about this for a long, long time. And in some areas, we just kind of scratch the surface. In other areas, we go from 100 level to advanced level fairly quickly there. We ended up talking for over an hour. And so trying to figure out what to put in, we needed to leave out was difficult. And so we actually just decided to chop the conversation in two. And so today we're going to get part one, kind of focusing on, some of the basics, if you will, right? We're going to review the indexes, what they're for, talk about why people use them in different scenarios, and things like that, comparing them, using GUIDs and primary, or using GUIDs for clustered indexes, things like that.
Wait, let me rephrase that. Not using GUIDs. No, not using GUIDs for your clustered indexes. Not using GUIDs.
Yes. Or what happens, right, if GUIDs are used for your clustered indexes?
Yes, I always have fun trying to explain that one. So, but we will get into all of that, whether it's episode 1 or episode 2, over the next 2 weeks. It's 2 episodes of indexing.
That's right. And then next week's episode, we'll get into a little bit more of the care and feeding, that type of thing. So the show notes for today's episode are going to be available at sqldatapartners.com/index, singular index. So with that, I guess let's go ahead and get into the conversation with Randolph. So Randolph, welcome to the show.
Thank you very much for having me.
Yeah, it's great. I know that you and Steve have done a little bit of work together, and some of your adventures have come up from time to time as we talked about it. And so it's great to have you here on the show with us today.
Well, thank you. It's been great fun working with Steve. He's a consummate professional, and I would hire him. I'm just saying.
There you go.
And technically, I would say I would hire you too, because we've done that on projects.
Yes, we have.
So I think we first met on the Database Corruption Challenge in 2015.
Has it been that long?
Oh, yeah, it has. Yeah, you did an amazing job on some of the corruption that we worked on there. And then you and I have worked on fixing a couple of corruption issues for clients since then. And then we also worked together on another project, sort of a longer-term disaster recovery, moving to Azure type project for a client.
So today our topic is indexes. Now, this can be a pretty broad topic, and just some of our pre-planning, we thought, gosh, there's no way we're going to be able to cover it all. And some of the components are just a little too complex to potentially discuss all of them over an audio format, so additional format. So some of that will be pointing to our show notes and pointing people to additional documentation there. Let's start with that conversation and kind of, I guess, maybe even defining an index and how that works. So the first one so when we talk about indexes, we're talking about copies of data, the way our data is structured, right? The very first example we have of that is a heap. Basically, a heap is a table with no indexes on it, right? So there's no structure or order into the way that the data is saved. Obviously, you have columns, you can have data types and all those kinds of constraints, but the way the data is actually saved is not part of the definition, if you will, of the table. That makes it a heap.
So then really from there, we take a look at how do we get to the data faster? Because with a heap, to find any specific piece of data, you've really got to search through the entire list or the entire table and look at every single row. Looking for, is that what I'm looking for? And eventually, if you've looked through the entire pile, heap in this case, you come back with a result. But another way to do this is by reordering some of the data. And the way I like to think of it is sort of like a phone book or a phone list. And I know growing up, I'm used to seeing the yellow pages and the white pages. And the yellow pages were the business listing, and the white pages were the listing of every person and business with a phone number organized by name. Now, if you were to just take everyone in that phone list and just put them in a random order, perhaps in the order that they signed up or purchased their phone service, that's sort of the equivalent of a heap. There's no specific order to it that's useful for searching on it, unless, of course, maybe you were searching on the order that they got their phone service installed. But it would make it really impossible for anyone using that phone book, if they were just in that order of one, just random order basically, to find anybody's phone number. So what they've done with the white pages is they've organized all of the people ordered by last name. Then when there's multiple people with the same last name, you have the first name order. And when there's multiple people with the first name, you have the middle initial order. And that's really the equivalent of creating a clustered index on last name, first name, and middle initial. And what that effectively does is it orders the entire table, or phone book in this case, by those items, so that when you need to do a lookup and you're looking for someone whose name is Smith, you don't have to start through the A's and go all the way through to the Z's and confirm you found all the Smiths. You can just jump to the S and then S section and then track down where Smith is from there fairly quickly. So then we look at the yellow pages, and the yellow pages are the business listings, whereas the business is organized by business type. So if you're looking for an accountant, you can jump to the A section, find the section where all the accountants are, and then for an exterminator, you need to go to the E section for exterminators, and then you can find the list there. Now, with the yellow pages, it's sort of like a filtered, non-clustered index, in that it's a copy of the data that exists in the white pages, but it's ordered differently. And the reason it's a filtered is that it only includes businesses. So we're kind of throwing two things in there. One, it's a non-clustered index in that it's a copy of the data. And two, it's filtered because just people have been thrown out and only businesses are shown.
Right. One thing that's kind of important there is that filter won't necessarily change, right? So that category of business, you're not going to take that out of your system. You can potentially filter on dates. You're not going to be keeping an average, for example, of 90 days in an index. That wouldn't be a good use of an index. But if you only wanted to see, like, from example, the beginning of 2017 forward, that might be an option, something like that.
Right. So then next, if you had what's often referred to as a reverse phone directory, it's typically not included with your white pages or yellow pages, but it would be ordered by phone number, so you can look up a name, where that would be the equivalent of a non-clustered index or a copy of some of the data that's been ordered in a different way to make it quicker to find something. So if you want to find out who has the phone number at 555-1212, well, you can look it up by the phone number and then find out their name. And that would just be a plain old non-clustered index with no filtering in that case, because it would have the entire list. So not sure if the yellow pages and white pages are international or available in all countries, but hopefully everyone has understood where we're going with that as the example on how those indexes work.
Yeah, that makes sense.
Thoughts on clustered indexes versus non-clustered indexes?
Well, the clustered index should be chosen very carefully because your entire table is going to be sorted according to that column or set of columns. And what you're looking for is a unique value for every row. And you want to make sure that the clustering key is narrow so that it doesn't take up that much space, because that clustering key is reused in non-clustered indexes, because you have to have a way for that copy of the data to match back to the original table. So the way that the database works is it stores the clustering key, the clustered index, inside the non-clustered index so that it can match back. So your clustered index, your clustering key has to be narrow. It has to be unique, preferably, and ever increasing. So what you don't want is a random value, because for a number of reasons, which we can get into later, a random value causes something called page splits, and it kills performance, and it kills the way the storage mechanism. It just makes things ugly. So you want a number that's ever a big integer if you're going to have more than 2 or 4 billion rows. It's just, you have to choose carefully.
One of the things I like there about that idea, I guess we can kind of jump in there. So you mentioned, page splits. And so even Steve using the analogy of the phone book, it's an example. But if you think about taking pieces of paper, right, and then basically writing on them and filling that up, that's kind of the way that SQL Server works. And these pages, at least in SQL Server, are 8K chunks, right? And so it has to sort them. So when we talk about that sorting and the clustered index rather, it's going to store them in that scenario. And so I think to your point is that when you're doing that in kind of a random order, it has to resort that every time. And then those pages can get out of whack, because then all of a sudden I've got to fit in data that wasn't there originally.
Exactly. So what happens there is you have to wait for the index to be resorted. That can take time. It can kill your performance. Is clear of wide random columns for a clustering key or a clustered index. For example, GUID columns are not a good choice for a clustering key. That doesn't mean they'd make a bad index, but they would make a bad clustered index, because remember, the entire table is sorted according to that index, because the clustering key is how your data is sorted, and that is your actual data. It's not a copy of the data.
So it's worth asking at this point, right? So maybe like a small little poll here. So we talk about non-clustered indexes, and then which are separate and different from, but they go hand in hand with primary keys most of the time, right?
There's an interesting conversation here. Microsoft, for I think a good reason, it wasn't the right choice, but a good reason, decided that if you create a primary key inside the Management Studio Designer, and in fact even before there, in previous Virtual Enterprise Manager, I think it was called in the old days, if you create a primary key on a table, it will automatically make that primary key a clustered index. I think the reason for that default was because they wanted you to have a clustered index at least. And because a primary key is unique by definition, it made sense from a designer point of view, and for people who are not intimately familiar with internals, to have at least a unique value as your primary key and also as your clustering key. So it makes sense from that point of view, but it can run into trouble because, let's face it, a GUID is unique. It's a very good candidate for a primary key, but it may not be a good candidate for a clustered index. And in fact, it isn't. So there are reasons why you would not want to use the designer on particular tables. In fact, I prefer not to use the designer anymore when I'm creating tables, because it has a bunch of defaults that may not be appropriate for the design that I'm implementing. It doesn't mean I don't use the designer. In fact, I use it a lot for creating relationships and stuff, because it's easier. In terms of clustered indexes and primary keys, the designer will make that the same column or the same set of columns. So it's just something to watch out for.
Well, now, having said that, from a poll perspective, what percentage of time are your clustered indexes different from your primary key?
Well, in my case, 1%.
Yeah, I think I would put that really into two camps. One of them is if it's a new database that I'm architecting from scratch or new tables that I'm building out where I have control over it, oftentimes they may end up being different, the clustered index versus the primary key. But if it's a, third-party application database that I'm jumping in to do some maintenance on or something, like 99.9% of the time, those are the same.
Okay. That's been my experience as well. Most of the time. Okay. That's been my experience as well. Most of the time, right? Yeah. So that 99.9% of the time, it's pretty much like when I've identified an issue, or they have, for an instance, a GUID as their primary key and not in the clustered index, that then we decide, hey, maybe we should make a change here, right? So I got some feedback. I've just put out this book, Zero to SQL, because I actually put this sentence in there. I said, when talking about non-clustered indexes, I say we don't have to include the primary key of the table in the non-clustered index, as this automatically gets included in the index. Now, somebody kind of took me to task, and they're ultimately correct in the sense that, oh, well, it's not the primary key that gets added. It's the clustered index that gets added. But I just thought it was curious. I'm like, well, how many times is your primary key not your clustered index? That's kind of where I was going with that.
Yeah, or design from scratch, as Steve said. You might have a reason for that.
So I guess you had just gone into a little bit of talking about how you said in the book something about not putting the same columns that are in the primary key into your non-clustered indexes because they are included there as well.
Yeah.
Mm-hmm.
And what was the feedback that you got on that?
So technically correct. It's not the primary key that gets added. It's the clustered index that gets added to the non-clustered index.
And in fact, there's a little bit deeper depth into that. Is it gets into the leaf node, guaranteed. But if it's a unique index, then it's not in the intermediate levels, if that matters.
Okay. And so here, when we start talking about, this is part of the index that will be a little bit hard to describe over the audio portion. But one of the things we kind of came up was that the idea of the game of the $10,000 pyramid, or even pyramids, the card game, if you're familiar with that. And that idea that, you have a structure at top, and then there's, the data kind of goes in this pyramid format. And that's one of the things that Randolph mentions there. So they have, leaf nodes and other types of names, if you will, for some of those sections, so that as SQL Server is looking through the data, it can find, do I need to keep going or not?
So really there, when the index is being used, it's that pyramid or like a tree type structure. And it uses that to be able to quickly jump to the pages that you're looking for. Rather than scanning every leaf node, it goes through that tree to get to the data quickly. Randolph, did you want to talk about the B tree and how that part works?
Well, it's difficult to speak about with just audio, but if you think of the top of the pyramid, there's only ever one page there, and that's called the root node. Only ever one page. It's also an 8K page. The type of page, instead of being a normal data page, is called an index page. But otherwise, it's exactly the same as a table structure or a clustered index. Because remember, the clustered index is your data. So your non-clustered index and your clustered index have a similar structure. You've got the single page at the top, and then inside that page are references to other pages, and those pages contain the index information. So if you need to go to Stedman, you would look on the root page for where the S's start, and then it tells you which page to go to where the actual data is. And then inside there, it'll be able to find the data much quicker than having to read the entire table to find Steve Stedman's number in there.
Almost like an index of sorts, right? Like a data index.
It's exactly what it is, right? It's just an implementation detail of exactly what you're talking about. You flip to the back of the book, you look for S, there's Stedman, and you know which page to jump to. That's exactly what's happening.
One of the differences with that is that the amount of time it takes to get there is that if you're just going through a heap or a clustered index that isn't clustered on last name and you're searching for me, Stedman, if there's 1 million pages in your table, you'll have to touch all 1 million of those to check and see, to find the rows with my last name on it. But with the index and that tree structure there, you might have to read 2 or 3 or 4 pages, depending on how deep that index is, to get to the S section, and then scan through just a few pages once you're there to find Stedman. And the difference is you're touching maybe 8, maybe 10 pages.
Yeah, 10's a lot for a seek. Yeah. So what you've just described, if you're checking the entire white pages or the entire index, that's called a scan. And if you're just looking for a particular record because you know how to get there through the index, then that's called a seek. Now, there's a whole conversation here about which is better. The answer is none of them, because it depends on what you're doing. So
Sure.
if you need 10,000 records, a scan is much more efficient than if you just need one. So a seek would be more efficient if you're just looking for one or two records. But if you're looking for, and then a scan would be much more efficient because it would only need to read fewer pages in that respect.
Yep, good point there. And I think that's one of those that it comes back to really what is it you're trying to do? And sometimes the query optimizer has to guess at what it is you're attempting to do with your query. And usually it gets it pretty close, but sometimes it's not quite right. And you end up with a seek when a scan may have been better or vice versa.
Yeah, and
Sure.
that gets into conversations about, are your indexes correct? Are they stale? Do they need to be updated? Do they need to be maintained? There's a whole bunch of stuff here that we can talk about. There's statistics as well.
So I guess we can jump into some of that. And I mean, before we do that, I think one of those ideas is, are my indexes good enough? Because the optimizer can do some different things based on the information that it has, right? And so there's this idea of a covering index.
Yeah.
Take us through that.
So what happened? Yeah.
Take us through that.
So what happens there is we spoke about the structure of the index briefly, where you've got your root node, you've got your leaf node where your data is, and then there's the intermediate levels. What happens with an included column is that if you have a table where you need to bring back the last name, the first name, the telephone number, but there's a whole bunch of other data in there as well, then your index would only need to contain those 3 columns. But let's say that some of your queries that happen quite often would also require a middle name. You could add the middle name as an included column. That middle name would appear in the leaf level, so the bottom level of the index, but it wouldn't appear in the intermediate levels. And that's called an included column. So your index doesn't have to be huge if it had all 4 columns, because you wouldn't be using it for all of your queries, but it would be a suitable covering query for the one that requires the middle name. I hope I haven't confused everybody by saying it.
More detail on the covering index, because sometimes when I talk about covering indexes, people say, oh, how do I create that? Is that a different create statement than a non-clustered or a clustered index? And the answer to that is really no, in that a covering index is simply an index where all of the data that you're asking for in your query happens to be in that non-clustered index. And it can return it all back to the query without ever touching the heap or the clustered index. But if it's not covering, what that means is it uses that non-clustered index to find the rows that you need, and then it jumps back to the heap or the clustered index to bring in the data that you're looking for. So that last step to jump to the heap or non-clustered index, that's skipped in the covering index, and that can save quite a bit of time too.
Yeah.
And that's when your execution plans, you'll see that lookup, right? And that's what that's doing. It's basically, I don't have all the information I need, so I need to jump and go grab it, right? So whether you should then create a quote unquote on, what's the performance of that query, all those kinds of things.
And how many columns there are in the lookup and all sorts of stuff. Yeah,
that's right.
It's an art, it's not a science.
Right.
So then with that, when you're looking in at the query plan and there is a suggested index, and I see these quite often where it says suggested index with 2 or 3 columns, and it includes like 25 columns in it. That kind of thing would certainly give you a covering index, but what are your thoughts when SQL Server is suggesting those type of indexes?
Don't do that.
And why?
Okay, so when SQL recommends a missing index, it is only specific to that query. And if we know anything about query plans, you can add a space to a query and it'll suddenly be a different query plan maybe. So don't just create missing indexes as they come up. What you need to do is to evaluate against other missing indexes or other recommendations for indexes on that table, and maybe combine the different recommendations into 1 or 2 new indexes, or modifying existing indexes that try and accommodate as many of those recommendations as possible. Because an index that includes all of the columns of the table, you might as well just be querying the clustered index. It's just not efficient.
So one of the things that looking at performance tuning and you're looking at maybe indexes that are inefficient or are not used, oftentimes you see them named something like missing index name, which is a clue that somebody just copied and pasted from the suggested missing index and ran it, and then they end up with an index that may not be really what they're looking for there.
Yeah. And in fact, this goes back to Penel's interview that you did in December, where he said his reference point is, do you have more than 10 indexes on a table? He's going to start looking into that and see why. Because you can have on a legacy system or even a vendor system, third party that you're not allowed to touch. People have over the years gone and added indexes because it helps with a particular query. And you can end up with duplicate indexes or indexes that are only different by, say, an included column. You've got all of that maintenance that's going into keeping these indexes up to date and statistics and all the other stuff that goes with that, when in fact you can consolidate and reduce your indexes quite easily by just analyzing the system and how those queries are running. And yeah.
Okay, so then let's say I've got too many indexes like you're talking about there, and some of them are not efficient or they're not being used. They may help someday with some query, but what are the negatives to having too many indexes? Specifically, what's going to slow down when you've got too many of those?
Well, there's two things that I'd like to address. So the first thing is, if this index is useful once a month, then create it once a month and then drop it again. So if you've got a reporting style query that has to run once a month and generates a report, and without the index, it would take 10 times as long, go ahead and build that index just before the report runs, and then afterwards drop it. Because it's not any use 28 days of the month or 29 days of the month. There's nothing wrong with you creating and dropping the index when you need it, as long as it obviously doesn't impact business hours. That's the first thing. The second thing to answer the question is, every time you modify the table, it has to make sure that the indexes are up to date. So if you've got 10 indexes or 15 indexes on a table, it's going to have to, every time you insert or update a row, or delete, in fact, which is the same as an update because it's changing the data, you've got to make sure that that row is replicated, or the change of the row is replicated in each one of those indexes. So it has to lock the table and it has to lock the indexes while it's updating them. And that can cause performance problems in and of itself. And it can also cause problems because you are locking data, so you cannot make any changes. You cannot select from that unless you start using tricks that you shouldn't be using, query hints, which I'm not even going to mention, because you have too many indexes and you're trying to satisfy a possibility that might happen in the future, when in fact you've got statistics that tell you, DMVs that tell you exactly what's going on with your database. Use the information in the query 2000 anymore. We have better ways of analyzing how your queries are running.
Okay. So then one of the things that often comes up, and it's highly debatable, I don't know, in places that I've been recently, is fill factor and the concept of what's a good default fill factor setting and what does that really mean to your indexes?
Okay, well, fill factor in theory is about leaving enough space in the data pages themselves so that if you do need to add columns and it is a random type of column like we spoke about before with GUIDs, it leaves space in the data page so that it doesn't have to split as often and it can go and insert data into those pages without having to resort the entire index every time. That's kind of what it's about. Do you want to add anything on that definition?
Well, I was just thinking, I heard a debate a while back about someone arguing that with SSDs and faster storage, that your fill factor changes over spinning storage. And I think that, I don't know if I entirely agree with that.
I completely disagree, because all that an SSD is doing is making your problems go away until a later time. The problem is still there. It's just being hidden by the fact that you've got fast memory. It's just that happens to be cheaper than trying to fix your indexes.
Right. Okay, so with fill factor, I think what we end up seeing oftentimes is that people will have a default fill factor setting on their database, and they think that that's going to cover whatever they need there, and it's going to be right for all occasions. But really, it comes down to that fill factor needs to vary depending on the data type, the frequency of change, whether the data going in is sequential or an ever-growing, or whether it's completely random. So fill factor really depends on the data there.
Did you have different fill factor settings based on your clustered versus non-clustered indexes? Because that's kind of would be a good sorting factor in the sense that, in theory, we talked about our clustered indexes, again, assuming that they're unique, that they're ordered, that you shouldn't be seeing as much fragmentation there because, again, they're kind of in that order. Kind of going back to the idea of them being in the primary key or unique. Ascending, they're just going to keep going. Identity is a good key or unique. Ascending, they're just going to keep going. Identity is a good example of that. It's the clustered indexes that are going to be a little bit more random, if you will, and you could see a little bit more shuffling.
So the magic word you used there was fragmentation. This used to be a huge problem, as Steve mentioned, with spinning drives. While I disagree with the fact that not worrying about fill factor at all is okay, I disagree. You should worry about fragmentation. You should worry about these things purely from the point of view of knowing that your database is in a good condition, is well maintained. At the same time, though, index fragmentation with faster drives doesn't matter as much as, for example, making sure that your statistics are up to date. In fact, I now say in my performance tuning sessions, if you want to get the best benefit from your maintenance window, it is far better time spent by updating your statistics than to, for example, rebuild an entire index. Firstly, from an I/O point of view, you need a size of data space for large tables. If you're going to be doing an index rebuild, it's going to need transaction log space. It's going to need space in the data file itself. It's going to need a lot of resources and memory and all of those things. And if you're replicating, it's going to replicate down. It's a big deal if you rebuild a large table, whereas it's a much more effective use of your time to do a statistics update. And the benefit from having an index rebuild versus your query plan being more effective, fragmentation is less of a problem now. So from that point of view, Steve, yes, I will agree with your statement before about fill factor. But yeah, the one thing I wanted to mention on fragmentation is that there was some confusion a few years ago. Fill factor of 0 and fill factor of 100, what's the difference? There is no difference. They're exactly the same thing. 0 fill factor means there's zero space left on the page. Fill factor of 100 means it's 100% used. So it's the same thing. I don't know why they decided to distinguish, but who knows? It's Microsoft. The fill factor is a percentage from 1 to 100, so 0 is 100. What you want to do there, as you mentioned, depends on the type of column you're addressing, less so the type of index you're using, but more about the type of column. So a GUID, as we've spoken about before, is a random value. So you would want to have a lower fill factor on that index for that type of data, because then it reduces the number of page splits, which reduces the amount of fragmentation. However, you will still need to maintain that index from time to time to make sure that the fragmentation is reduced.
Yeah, one of the interesting things I've come across there is that if you're in a scenario where somebody has a GUID as their primary key and as their clustered index, and it might be in a position where that one of the workarounds that I've found there is to use the new sequential ID rather than new ID, so that you can turn GUIDs into sort of a pseudo ever incrementing value.
Right, and that's 16 bytes wide. So
yep, it's still big. It's still
big, but it is sequential, as you mentioned.
Yeah, and it's better than random at that point.
It is better than random, but the reason people use GUIDs is usually from a development first perspective. So the developers want to manage the primary key in the application as opposed to the database handling it. For a number of legacy reasons, that was a good idea 15 years ago. It's not a good idea now. There are a lot of habits, and this is the way we do things happening from a development side that are not being, well, the new stuff in SQL Server is not being adopted as effectively because there is 15-year-old news on the internet that says SQL's not good at this. So the other thing is we have to educate SQL's not good at this. So the other thing is we have to educate people to say, listen, there's a reason this RDBMS is in the top 3 in the world. There's Oracle, there's MySQL, and there's SQL Server. Those are the top 3 RDBMSs in the world, a relational database management system. So SQL Server is in the top 3 for a reason. It's a good product. It's in fact one of the best products out there to handle your data. So you should be using the newer features and the newer compatibility levels and things like that, and get away from the old habits of 15 years ago, because they're bad habits and things have gotten better in the last few years.
And that is oftentimes a challenging debate to have. And I found that to show examples or to come in and show what the performance difference is between one way of doing it versus the other way of doing it is a good way to show to show what's better there. Okay, so then another one as we talk about just the different options around indexing that we have is the concept of filtered indexes. And I know I threw this term out when we were talking about the phone book directory around the business names and the yellow pages. So filtered indexes, any thoughts on pros and cons and sort of how that works we want to talk about here?
Well, the idea of a filtered index is that if you have a very particular condition in your where clause in your query, let's say that you want to grab all of the statements in the phone book where their middle name equals J or starts with a J. If that where condition happens often, then you could create a filtered index that uses that condition, that where condition, and then the index will only include those rows that satisfy that condition. The problem with the filtered index there is that if you use a parameter in your where clause, it's not going to use the filtered in your where clause. It's not going to use the filtered index. So it's solving a very specific problem, in my opinion. It's a good problem that it solves, but it's a very particular way of solving it. And you have to be careful when you create your indexes and create your queries that you're using them correctly.
So a real world example I came across there that filtered indexes were very handy was around a very large table and needing to purge data beyond a certain date. And I found that when I just ran delete statement to delete where something was older than a given date, it was forcing a large index scan to find that.
Right.
And it was taking like 40 minutes to delete 1,000 rows. And then what I did instead was I went in and I added a filtered index and did it deleting one day at a time that was beyond the date range. I added a filtered index just for that one day. That filtered index gave me the shortcut to be able to delete 1,000 rows at a time rather than extended amount of time to delete it. And I found in that case, I could add that filtered index, do the work I needed to do, and then drop it, and then add a new one when I was working on a different day. That was a really handy way to use it to improve performance there.
Yeah, that's an excellent example of when a filtered index would make a lot of sense. Another example is if you have a very large table and you have a bit type field where you've got nullable values, it's a nullable column, and you've only got a few of those rows that have a value of true or false in, you could have a filtered index on either the null values or the populated values, depending on what type of query you're writing. And it can identify those columns or those rows that have that bit column set much more easily.
Yep. Another good example
Exactly.
there. So
yeah, that's been
Okay.
my experience as well. Okay.
Well, we're just getting started.
That's right, and never a dull moment. I think one of the reasons I had given pause to the idea of talking about indexes was, I wasn't quite sure what we could do with it, and I'm actually really glad that Randolph was able to come on to the show. Lots of good information, and of course, I think the conversation flowed really well, and lots of different interesting points.
Absolutely. And I think that if we could have, sat there and listened to the whole thing straight through, would have been good, but we've split it into 2 weeks, so you can listen to some this week and some next week. And
Right.
hopefully everybody will learn something along the way.
Yes. If there's something that you thought that was interesting, or you just have a question or another comment, right? Of course, you can reach out to us. We're on Twitter. I'm at Carlos L. Chacon.
And I'm at SQL EMT.
You can always use that hashtag SQL Podcast. Let us know what you think and give us that feedback. We're interested in getting other people's opinions, right, on how these conversations go.
Or you can go to the SQLDataPartners.com website and leave us a recorded message and risk possibly having it included on the show.
That's right. I've been a little bit sad there. No one has taken us up on that yet. And,
Yep.
So maybe we need to have a special prize or something for the first one.
That's a good idea. And maybe if anybody wants to ask a question or just give us some feedback, we'd love to hear it and put it on the show with us.
That's right.
So if you want to be on the show, but you don't want to be a guest, that's the way to do it.
That's the way to do it. Okay, so our music for SQL Server in the News is by Mansardian and is used under Creative Commons. I think that's going to do it for us today, or for this show this week. Any last things, Steve?
We'll see you on the SQL Trail.
Bye, compañeros.
Did I say that right?
Yeah, you did great.
SQL Data Partners.